Hello, ladies and gentlemen of Statistics 2. So, one of the things I noticed as I was working through your homework, or what was being told to me from your classmates, is that in general, problem 57 was giving people some problems. So, I thought I would go through this problem to help you feel like you're going to be a little more successful with this one in the future. So, 57, the one on cereal, and a couple of the others were all about adding together different normal distributions and then getting some results from that. So I'm going to walk you through this problem and give you a good solution of it and what it's going to look like. Please be a little patient with me. This is my first time using the digital pen on my computer, so this might get a little rough. Alrighty, draw with touch. Go ahead and make this bigger. Okay, so let's start by reading the problem. At a certain coffee shop, all the customers buy a cup of coffee, and some also buy a donut. The shop owner believes that the number of cups of coffee he sells each day is normally distributed with a mean of 320 cups and a standard deviation of 20 cups. He also believes that the number of donuts he sells each day is independent of the coffee sales and is normally distributed with a mean of 150 donuts and a standard deviation of 12. So we notice we have two variables floating around in here already with different means and different standard deviations, and that they're independent. At least that's what the owner believes. So I'm going to go ahead and start writing what I know a little bit, even before I know the problem, getting started, before I even have a question. So the first thing I notice is that I have two things floating around here. Coffee, which I'm going to call C. It's not bringing up my pen. Okay. Coffee, which I'm going to use the variable C for, which is normally distributed with a mean of 320 and a standard deviation of 20. And then I have the second variable, donut, which I'm going to use a D for, which is normally distributed with a mean of 150 and a standard deviation of 12. So I'm just summarizing what I know so far. And then I'm going to go ahead and get into part A, which is just, oh, sorry, I scrolled too much. The shop is open every day but Sunday. Assuming day-to-day sales are independent, what is the probability he'll sell more than 2,000 cups of coffee in a week? So for part A, we notice that he wants to know what's going to happen in a week. And if you look at this, he's defining this new variable, which is 6 days a week being sold coffee, and then he's asking this probability question. So I need to set up this variable first, which I'm going to call W for a week, which is going to be adding, and I'm only doing coffee sales here, because he's only asking about cups of coffee. So I've got coffee for one day, plus coffee plus the second day, so this is like Monday, Tuesday, Wednesday, Thursday. Okay, I'm getting bored. Dot, 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 up till he hits the 6 days of the week that he's open. Okay? One of the things we should notice about this distribution, well, before I even get into that, we know that this is going to have a different distribution than what we've seen in our previous two distributions. So we're going to have to make a new one, and we're going to have to find its mean and standard deviation. So the first thing I'm going to do is I'm going to notice that, W should be normally distributed, right? And we got to find its mean and standard deviation. So its mean is just going to be the sum of the means of the coffee distribution. So it's going to be 320 added to itself, 6 times, which I'll do that calculation and then post it up here. Eraser, it's not working. Great. Oh, there we go. And then the standard deviation is going to be the square root of the variances all added together. So I need to come up with the variances, which is 20 squared, just like we did in class. And I need 6 of those as well, so I'm not going to write them all out. And I'm going to pause and do that calculation really quick, or just arrow down a little. So I get that W is normally distributed, after I add these all together, with a mean of 1920 and a standard deviation as the square root of 2,400. And when I go to calculate this, I'll round that a little, but I'm not going to do that yet. I like to end my roots so it's clear where they stop. Okay, so, as a little side note, we know that the square root of 2,400 is just slightly bigger than 48. So 48 well, not slightly bigger, it's almost 49. I'm going to use that is what I'm rounding it to. Again, you have some elective choice there. Then let's actually look at what the question is asking for us. It's asking us to figure out how likely it is he sells more than 2,000 cups. So how likely, we think of as probability. So I want the probability that my week is greater than 2,000. So I'm going to use Z-scores to figure out what that is in a Z. So that would be z is greater than 2000 minus my mean I just found. This is why I bothered to find the mean, divided by my standard deviation. Woohoo! Okay, and so that'll be the probability that z is greater than, so you could calculate that little fraction right there, and I got 1.632, yoink. Now at this point you could either fire up Minitab and plug that in there, use your calculator using the standard normal calculations, or you can, no, I'm not on mouse anymore. Or you could go ahead and pull out your table. Either one. If you use the table, first you're going to have to write it as a left probability, which means you need to do this as 1 minus the probability that z is less than 1.632, because the probability you're looking for is, so I'm doing the standard normal, which has mean 0, 1.632, and then this stuff. Okay. All right. As we proceed forward, if you bother to calculate that, you should get about, well, at least I got, and I'm rounding here, 0.051, or at least around that. Now, if you use different calculation method than what I did, you would get something slightly different. I use the standard normal table. Okay. So let's get on to part B. Woohoo! And I've already forgotten what that question is. So if he makes 50 cents on each cup of coffee and 40 cents on each donut, is it reasonable to expect that he will make a day's profit of over 300? So they're only asking about one day here, so we're not going to need our variable from part A since it was about a week. And it's asking about the two together, so you're going to be the sum of two distributions, and you've got this extra factor of cents there. And notice this is in dollars, not cents, so I'm going to have to convert the cents into dollars. So I'm going to define a new variable in part B. I want to use P for profit. I'm like really tempted to use P, but P, since P is also representing probability, is probably not the greatest idea in the world. So I'm going to use T for total, if that's okay. If you used a different variable, that's fine. T I'm going to define to be 0.5 times the coffee plus 0.4 times the donuts, because again here I'm doing 50 cents per cup of coffee, so in dollars that's 0.5, and similarly for the donuts. And then I need to figure out T's distribution. So T is going to be normally distributed with mean 0.5 times the mean of coffee, which was 320, plus 0.4 times the mean of donuts, which was 150. And I'm not going to be able to fit the standard deviation here, it looks like. The standard deviation is going to be calculated just like how you'd expected. It's going to be I'm drawing the square root of 0.5 times the standard deviation, which was, of the coffee, sorry, which was 20, not 120, that's supposed to be a parenthesis, squared plus 0.4 times the standard deviation of the donuts, which was 12, squared. So when you do that all out, T is normally distributed with a mean of $220 and a standard deviation of $11.09. Now, what's suspicious about this is you should look at that as, oh, well, that standard deviation is not very big, and that mean is not very close to 300, so I'm a little suspicious already that this isn't going to be very likely, because the probability we want to know is how likely is it that he makes more, or his total profit is greater than $300. But I'm highly suspicious that's not even going to be good. So I'm going to go ahead and change this into a z. So I want the probability that z is greater than 300, my score, minus my mean, 220, divided by my standard deviation. I did round that standard deviation, but I rounded it money-wise, which is why I only did 2 decimal places. So if you calculate this, that's going to be the probability that z is greater than 7.21. Wow. Okay, so this means that I'm looking for stuff that's greater than 7 standard deviations away from the mean. And we know that from the 68, 95, 99.7 rule that 99.7% of the data is within 3 standard deviations away from the mean. So when I go looking out at something that's even greater than 7, this is 0. There's just no way. There's just no way that's true. So it's like, no way is he making that much. Poor guy. But $300 a day, that's kind of a lot of money, right? It's like, no way. For the exact reasons I just described. Normally I would type that out, but, you know. Okay. let's go on to part C. So I'm going to need to scroll down again. Okay, so in part C, they give us this rather interesting idea of he wants to know how likely it is that he will sell, is it more donuts? Yeah, sorry. What's the probability on any day, just one day, so not multiple variables added together, he sells a donut more than half the time he sells coffee to his customers. So I think about that and I'm like, okay, so he wants to sell donuts more than half the time he sells it to customers. And this is where things get a little confusing because you're like, well, where's my variable? That's the probability I'm interested in. And I agree with you. Let's adjust this a little bit. So I'm going to subtract the c to the other side because then this becomes easier to calculate. So what you get when you do that is you get d minus 1/2 times the coffee is greater than 0. So that's a probability I'm going to find. I'm going to figure out when is this variable greater than 0. So I'm going to define a new variable, which I'm just going to call x because I'm running out of creativity today, to be, I meant to do an arrow there, sorry about that, not lasso, eraser, equal to d minus 1/2 c. And x is going to be normally distributed with mean, donut mean, which is 150, minus 1/2 of the coffee mean, which is 320. Ooh, that 3 looks awful. Square root, and now I gotta square this guy's standard deviation, which was 12, minus 1/2 of the 20 from the standard deviation of coffee squared, and I'll calculate that out for you. And that gives you that x is normally distributed with a mean of -10 and a standard deviation, which is the square root of 44. That one doesn't come out too nice. I'm going to leave it like that. If you were looking at this and wondering, like, what? Negative numbers? It is quite possible for your mean to be negative. It's only the standard deviation that if you get to be negative, you should be concerned, because remember, standard deviation is representing average distance from the mean, and distances cannot be negative. So what I'm really asking here, up here for my probability statement, which I did in red. So I want to know when d minus 1/2 c is greater than 0 is going to be the same as asking, well, where is x going to be positive for this new variable x? Alrighty. So to calculate that, I'm going to do a probability. So I want to figure out where x is greater than 0, and that's going to be the same as doing where is z greater than, and here I got to do my standard normal calculation, so minus my mean, which is -10. Oh, my negative came out bad. Hold on, I'm going to rewrite that. Oi, oi, oi. Minus a negative. Oh, that looks bad. Okay. Square root of 44. Make some space. Okay. So if you calculate that z-score, I want to know when is z greater than, oh, tell me I calculated this. I did 1.5076 roughly. That's what I got. So if you calculate this, it's around like 37-ish percent. I don't remember what this is and I didn't write it down. Terrible teacher time. Woohoo! Where is my thing so I can pause it? There it is. No. This is my fancy laptop. Isn't it great? Except for it's really hard to get it out of tablet mode. Okay, we're back. Yay! So if you use the standard normal table, you got to do 1 minus the probability that z is less than 1.50. And then you don't have space to do this because it only reads to 2 decimal places. So if you're using the table, you got to use a 1 here, which is unfortunate. I'm going to round this a bunch, which is crappy. So I got to do 1 minus, where is this on the table? I'm going to have to pause this again. Okay, so now that we're back, I went and looked this up on the standard normal table, this probability. And again, I rounded here. So if you did this using Minitab or your calculator, you would have gotten a more accurate answer than what I did here. And then I'm going to subtract these two, and you notice that you get 0.06552, which is about what you should expect to get. So about 6% of the time he's going to sell more donuts to his customers than half the coffees he sells. So I'm hoping this helps you get through this problem and one similar to it. Seeing it done, I'm going to record a couple more of these, and hopefully that will help you with your homework. Have fun calculating.